Hello, everybody. In this in this video, we're going to talk about information assurance and the way that it has an impact on the way that we do our business in computing, and especially at web scale applications. So, what is information assurance? Well, it's a lot. Information assurance, if you take computer security, that's securing individual applications and individual pieces of hardware. Information assurance is a lot bigger than that. Information assurance is about creating a security conscious organization that everything they do is angled towards security. So security in this case is about much more than hacking. It's about everything that an organization does. Security is about things like architecture. If you remember that availability is a large part of what security really is about, then having a resilient architecture that can live with problems in different parts of the world and still provide its service to our users, that's an architecture that's much more secure, because security is about availability, than a monolith that is based on one server in one data center in one part of the world. So security is about architecture. Security is also about risk management. Now, risk management is a really big topic because risk management says that an organization recognizes that they're never going to be completely secure from everything bad out there in the world. You just can't do that. But what you can do is you can try and define the risks that you feel you're up against. You can prioritize those risks that you think are more likely to occur than others, and then you can uh, uh, think about which ones are worth protecting against. If a risk is really expensive, but the cost of the impact is very low, why bother with it? If that kind of risk exists, then you should just accept it as part of the being in the world and then move on. Prepare for it and move on. That's risk management, and it's something that companies think about all the time. Now, from my perspective, I think this one's true, but I admit it's provocative. That's okay. You can argue with me later about it if you really want to. So the only real security, computer security, that I see is on the server side. We've got this mandate, this rule of thumb that we always live with, that is that if somebody can get to the console, they can get to the keyboard, they own the machine. I don't think that's changed over time. I think that's still true. We used to just lock up our server rooms back when that's what we have, server rooms, and that was the way that we protected our server consoles so that only people who were authorized to go into the server room and type into the console that was attached to the server were able to do that. Well, security has changed now because our architectures have changed. We don't have consoles on the operating systems that provide our services. They're virtual machines. They're containers. They're located in data centers and cloud service providers. Who knows where. But that whole idea that if they can get to the console, they own the machine still applies. But in this case, it mostly applies on the client side. Now, what does that imply for what we need to do on the server side? Well, we used to trust certain users who would log into our systems and we would give them enhanced access rights on our servers. But now we have to be careful about that. And so yet we still have administrators, we still have people who can log in remotely to our servers and things, but we have to be much more protective about how we authenticate those users and what activities we allow them to do on our servers. So in this case, the only real security on the server side means don't trust users, don't trust administrators, and really figure out what those administrators should be allowed to do and only allow them to do those things. Physical security still matters just because of what we were talking about. Get to the console on the machine. Physical security still matters, but it matters in a different way. Uh, Physical security in this case may mean getting inside cloud service providers. It may mean protecting against the employees of cloud service providers whom we've never met, but are responsible for the physical security of the servers that run our applications. That's a scary thing. That's something that we need to be concerned about. Now, Amazon has an approach to this because, I remember when clouds first came around, people would feel real smart, really, provocative by saying, oh yeah, well, clouds are insecure. There's no way to secure a cloud. And that just seemed really silly to me. And it seems silly to Amazon too, I think, because what it didn't recognize was the fact that we have dual responsibilities. We have taken on a partner. If we push an application into the cloud, we have become a partner with that cloud service providers. And they have a job in securing our application, and we have a job in securing our application. Their job is to provide access, to provide availability, to make sure that their systems don't fail. Our job is to write applications that are secure and that we live up to standard security rules. Everything's encrypted on the client side as well as the server side. We keep track of we use HTTPS, we use SSL. We've got certificates everywhere. you know those kind of things. That's not Amazon's responsibility because it can't be. They can't do that. Only we can. So the shared security model that Amazon talks about, and you can go read about it if you want, makes a lot of sense. And it's one that we need to think about as we think about information assurance being much more than securing individual servers. So we have a bunch of ideas around information assurance. This idea of enterprise operations. When you work in an enterprise, things are different. And the way that we do our jobs is different. The way that we bring information assurance into everything that we do is different. And so you would find information assurance people who work at an enterprise who know nothing about securing individual machines because they have other jobs to do that are as security related as securing individual machines, but require a totally different skill set. Security is architecture. When we deploy our application into multiple data sets, we have failover multiple data centers. We have failover built between those data centers. We have resilient architectures where we have multiple copies of everything that we do. We take the time to build an architecture that's resilient to failure. That's using our architecture as a big component in securing our overall application. Security policies are very different when we think about information assurance. Security policies can be things like making sure that we know exactly who each one of our employees is. You want a problem with access to the machines? Use somebody's fake driver's license as the only identification you insist on when you make a new hire. Then you give them access to the inside of our network. Heck, you even give them a desk inside our network, and we don't even know who they are. So that's an example of a security policy that information assurance people work toward because it makes the entire organization much more secure. information or security procedures around information assurance are very different also. We will practice things like failover of different components within our architecture. We will practice things like having environmental uh, um, disasters that make it so that people can't get to work. And how can we make it so those people can either do their jobs remotely or have people in different parts of the country or the different parts of the world take over jobs for people who can't get to work in one particular facility. We have a hurricane coming into Houston probably this weekend. And so smart companies are already moving assets out of Houston. And primarily, a lot of those assets are going to be people. And those people are being put up in hotels in New Mexico and Alabama and those kind of places where they're with their families, of course, because nobody can concentrate if your family's in the middle of a disaster. But those kind of security procedures are standard procedure for companies that follow information assurance ideas. Auditing. Security is computer security is largely about auditing. That's why I had you spend so much time on those individual exercises of generating reports, counting things, keeping track of versions, keeping track of packages that were installed and what systems, what services were loaded versus those that weren't loaded. Those are all audit questions. And those audit questions get at the issue of, do we know what the configuration of our applications actually are, is, is, is. And can we show that the the operations that we've used on those servers and those applications has been tested sufficiently so that we can say that, as to the best of our ability, we know how this change in configuration is going to impact our application. We may be wrong, but to the best of our ability, we think that we're right, and we have built the testing protocols that we use against all our configurations before we push them into production. And we keep track of the results of those tests so that we can say, we know that these tests were run against this new configuration, and this configuration was successful in the tests that we ran against it. Compliance. The compliance things are things like, can be foolish things like, does everybody put their names and fill out the forms at the top of the changes that they make in software configurations? How do we make sure that people live up to the requirements that our company has around things like availability in the face of disasters, in terms of making sure that individual workstations are compliant to the security requirements of our organization. All these things are really important. And then last of all is this notion of risk management, which I talked about a second ago, which is the whole idea that we know that the world is a dangerous place and that we can't stop every risk that's out there. All that we can do is try and manage the risks that we know we're up against. Some we can mitigate, others we have to just accept as the cost of doing business. And that is an important set of requirements. So this last slide is kind of weird, and I admit it. So this is something that I took from a business journal, and they were talking about audits and internal control systems within individual organizations. Now, the thing about this that's interesting is that it's not written from a computing perspective. It's written by our business managers as they think about audits and internal controls. And so, but here's the secret thing. Just because this was written by business people doesn't mean that we in computing don't need to live up to it. We do. We are part of all the businesses that we service, and we have to live up to the business requirements also. It used to be that computing was this weird secret thing that happened in the back. Those days are long gone. And so we need to live up to the same requirements that all the other business divisions of our organization need to live up to. And so everybody does audits and they have internal control systems. Our business managers are going to live up to these requirements in the way that they run their accounting systems, their marketing, their fulfillment, their, all the traditional business functions. We have to also. So how organizations maintain environments that encourage incorruptibility and deter fraudulent activities. That's how they say audits and internal control systems. Management integrity is a big component of this. So management, so the managers who we report to, who help us figure out what we're going to work on every day, all that kind of stuff, they need to set the overall tone for the organization. If you have a manager who says, just get it done. I don't care if it works out well, just get it done. That's not living up to the requirements of management integrity. Managers need to be sincere about doing the best that they can for their organizations. That's important. Competent personnel, the ability to recruit and retain competent personnel, increases comparability of records from year to year. Records from year to year, that's not the way I would have taken that competent personnel, but it matters to us. You know, there's so many, when you get a new job, they might say, that we need somebody who's got this particular degree. And you're thinking, come on, I know how to do the work, but you won't hire me because I don't have the right degree. What's going on with that? This is what's going on with this. Your managers need to be able to convince the people that they report to that they have hired competent personnel. One way, perhaps correct, perhaps incorrect, way to judge the competence of people that you hire is the degrees that they have. And so, you guys are smart, you're getting the right degree for a good job in computing. But some people won't, and they'll wonder and they'll complain why they don't get the job, the promotion, but you do. This is why. It's that metric that says this person has the degree, this one doesn't, is one way for upper level managers to judge the competence of the personnel within the computing organization. Segregation of duties. This is a big one that trips up computing people all the time. So if you run a database, does that mean that you can change the records, you can delete the records, you can update the records, you can do all that kind of stuff? Odds are good that your company's gone through and cut way back on people who can both change the records and access the log files. Because when you change a record, it updates a log file and says, hey, this record was changed. If you can do both, then you, in effect, can cover up your tracks if you decide to change records and then you go into the log files and delete the log entry that shows that you did something. Well, in accounting, in purchasing, in all those different parts of the business, segregation of duties has been around forever. So the person who writes a request for proposal doesn't judge the proposals that come in. The person who opens the mail doesn't write the checks, because you want to make sure that the person who opens the mail can say, hey, who's this bill coming from? And why do we get a bill for something we haven't used that supplier in years? Send it over to the person who writes the check. The person, if that person opens the mail and writes the check, they can open up and say, there's the bill from my Uncle Louis, landscaping firm. I'll just write the check, even though Louis hasn't done any work for us in years. So it's those kind of things that segregation of duties is all about. So if you run a database and you find that you can only access certain records in the database, or the data that you work with spans two databases and you can only access one. This is why. It's a way to segregate the duties to make it so that one person can't do bad things, or at least the bad things they can do aren't that bad. Um, Edward Snowden is the classic example of segregation of duties. He worked for the NSA. He and I don't know, was it 3 or 4 of his buddies? I don't know. We're in Hawaii, not a place where you work really hard, as far as I'm concerned. It's all luau and hula hula. I'm just kidding. So he had access to a database, but not to the entire records. So he asked his buddies, he said, I need to generate this report or do this work or whatever it was, but I can't do it with just my own login. Can I use your login to do this work? And they said yes. And when they did that, they violated the segregation of duties. And then he was able to do all kinds of bad stuff. And now he's rotting in Moscow someplace, afraid to come home because he'll get arrested. So segregation of duties matters, and you're going to run into these things, and they're going to be frustrating. Why can't I do all of it? This is so stupid. It takes so much longer. This is why. Records maintenance, proper documentation exists for each business transaction. Isn't that us? Aren't we the ones that do the records maintenance? Don't we maintain the accounting databases and everything? Yes, but that's why we have to go through so much paperwork, so many databases to get anything done, because we're doing records maintenance. We're documenting the transactions that we do, so that even though a server is beat up, not working, a piece of junk, and you just want to throw it out, you have to sign it out of the inventory of servers that you work with. And it needs, even though it's broken and doesn't work anymore, it needs to go through the crusher to make sure that nobody else can fix it and access whatever data is still on it. Those are records maintenance kind of issues where we keep track of the servers that hit our loading dock, and then when they're deployed into production, when they're and used for their useful life, then we take them out of production, we destroy them, and then we send them out to the recycler. Records need to be kept all along the way, even for this broken old piece of junk server. Safeguards. So those safeguards are the things that prevent unauthorized personnel from accessing company assets. Let's go back to that piece of junk server, right? Who says it's a piece of junk? If you put it into production and then a month later you say, server's failed, I'll just get rid of it, and you don't need to trouble yourself with crushing it and throwing it into the recycler or whatever. I'll just get rid of it, and you take it home and sell it for $5,000 on eBay. Those are safeguards of it. I can guarantee that somebody's done that, or at least tried that, probably got away with it for a little while, but hopefully got caught. But those kind of things matter, and when you see the rules and stuff that you need to live up with, it's because of this that you have to live up to those rules. So I hope this was kind of interesting to you, and we do need to do our work within a business environment, and it doesn't matter where you work. Everybody's got to live up to the requirements around businesses and stuff. So take care, everybody. I'll talk to you later. Bye-bye.